So let's proceed to the cloud data flow. Cloud data flow is a managed service for developing and executing a wide range of data processing patterns including ETL, batch, streaming, processing, etc. Data flow is used for building data pipelines. This service is based on Beam and supports Python and Java jobs. The analogs and alternatives. So the analogs and alternatives of data flow is set up cluster on the virtual machines and run Apache Beam via in-built runner. So as I know, other cloud providers don't have analogs. It combines batch and streaming with a single API, very fast deployment, a fully managed service, no operation work, dynamic work rebalancing, and auto scaling. And the limitations are based on a single solution, therefore inherits all limitations of Apache Beam. So the maximum size for a single element value is streaming engine in 100 mH. And the pricing strategy is the cloud data flow jobs are billed in per second based on the actual use of data flow. The data prep. So data prep is a tool for visualizing, explore, and prepare data you work with. So you can build pipelines to ETL your data for different storage and do it on a simple and intelligible web interface. So for example, you can use data prep to build the ETL pipeline to extract raw data from GCS, clean up this data, transform no needed view, and load the data into BigQuery. So also you can schedule a daily, weekly, etc. job which will run this pipeline for new raw data. So the limitations of data prep is works only with BigQuery and GCS. The price strategy is for data storing, you pay for data storage. For executing ETL jobs, you pay for Google Data Flow. Benefits is simply building of ETL pipelines, provided a clear and useful web interface, automate a lot of manual job for data engineers, built-in scheduler, and lastly is to perform ETL jobs from data prep uses Google Data Flow. To the BigQuery. So a BigQuery is a data warehouse. It allows us to store and querying massive data sets up to hundreds of petabytes. BigQuery is a familiar to relations database by its structure. It has table structure, uses SQL, also supports batch and streaming writing into the database, integrated with all GCP services including Dataflow, Spark, Hadoop, and etc. It's best for use in interactive querying and offline analytics. So the limitations of BigQuery is it doesn't support transactions but who need transitions in the OLAP solution. Maximum size of the row is 10 MB. So the price strategy is you pay separately for stored information for each GB and for executed queries. So the benefits of this is huge capacity up to hundreds of petabytes, SQL, batch and streaming writing, support complex queries, built-in ML, simple stupid for now, serverless, shared data sets. You can share data sets between different projects, global locations. All popular data processing tools have interface to BigQuery. Next is the Cloud Composer. So Cloud Composer is a workflow orchestration service to manage data processing. Cloud Composer is a cloud interface for Apache Airflow. Composer automates the ETL jobs. For example, can create a data pro cluster, perform transformations on extracted data via Dataproc PySpark job. So upload the result to BigQuery and then shut down Dataproc cluster. So the limitations of these are provides the Airflow web UI on a public IP address and inherits all limitations of Apache Airflow. So the pricing strategy of this is you pay only for resources on which deployed Composer, but the Composer will be deployed to 3 instances. So the analogs and alternatives is custom deployed Apache Airflow other orchestration open source solution. R fills the gaps of other GCP solutions like Dataproc and inherits all benefits of Apache Airflow. No SQL big database service. It's the same database that powers many core Google services including search, analytics, maps, and Gmail. Bigtable is designed to handle massive workloads at consistent low latency at high throughput, so it is a great choice for both operational and analytical applications including user analytics and financial data analysis. So a cloud Bigtable based on Apache HBase, this database has a very big capacity and suggested for using if you have more than terabyte data. Bigtable is the best for time series data and lot data. So the limitations are has really bad performance on less than 300 GB data, doesn't suit for real time, doesn't support ACID operations. Maximum size of a single value is 100 MB. Maximum size of all values in a row is 256 MB. Maximum size of the hard disk is 8 terabyte, and the benefits are has a good performance on 1 terabyte or more data, cluster resizing without downtime, incredible scalability, support APA of Apache HBase. So now you are familiar with the main data services that GCP provides. So this knowledge can help you to build a good data solution. Of course, clouds are not panacea, and in case if you use clouds in the wrong way, it can very affect your monthly infrastructure billing. So very carefully build the architecture of your proposal and choose the necessary services for your needs to reach the needed business goals. So explore all the benefits of and limitations for each particular case. Care about cost and of course remember about the scalability, reliability, and maintainability of your solution.